Hello there, this is Pratyush Mishra and our today's objective is to complete stability factor and its derivation. So let's move on. On what factors does the operating point is dependent? The first one is ICO, reverse saturation current, and the second one is VB, base emitter voltage, and the third one is beta, obviously current amplification factor. Now move on to stability factor. The degree of stability of IC against variations in ICO, reverse saturation current, VB, base emitter voltage, and beta is expressed in terms of stability factors. Now, the different stability factors are S, stability factor S, and the second one is S prime. We can say it as SV, and the third one is S beta or S double prime. Now, move on to stability factor S. The stability factor S is defined as the rate of change of collector current IC with respect to change in IC or reverse saturation current, keeping beta and VB base emitter voltage as constant. So here is the expression of S. S is defined as DIC divided by DICO. Differentiate IC with respect to ICO reverse saturation current at constant beta and base emitter voltage. So the general expression for stability factor S is the expression for collector current IC. We all know that is IC is equal to beta times IB plus 1 plus beta ICO reverse saturation current. So differentiating with respect to IC, we will get 1 is equal to beta times DIB divided by DIC plus 1 plus beta times DICO upon DIC. And we know that DICO upon DIC is nothing but 1 by S. So on solving this, we will get S is equal to 1 plus beta upon 1 minus beta times DIB upon DIC. And we know that the ideal value of S is unity. The smaller the value of S, the higher is the stability. So to obtain the higher stability in our biasing, we have to keep the value of stability factor S as low as possible. And now move on to common base amplifier. The output current IC in the common base amplifier is given as IC is equal to alpha times I plus ICO, where alpha is also a current amplification factor, and alpha and value of alpha is equal to from 0.98, 0.95 to 0.98. It amplifies input signal, and it amplifies input signal. Input signal multiplied by 0.98 times the output signal. Output signal is equal to 0.98 times the input signal. Now differentiating with respect to ICO, we will get DIC upon DICO is equal to 1, because alpha times I is a constant value, so DIC upon DICO is equal to 1. So in case of common base amplifier achieves the lowest value of stability factor. Since it's 1, so it's the lowest value of stability factor, and so a common base amplifier doesn't require any stabilization. Now move on to stability factor SV or S prime. It is defined as the rate of change of collector current IC with respect to change in VBE base emitter voltage, keeping ICO reverse saturation current and beta as a constant. So here is the expression for S prime is equal to DIC upon DVBE, where ICO is constant and beta is also constant. Now move on to stability factor S beta or S double prime. Here, the stability factor S beta is defined as the rate of change of collector current IC with beta keeping ICO reverse saturation current and VBE base emitter voltage as a constant. So here is the expression of S double prime DIC upon DV at constant ICO reverse saturation current and VBE base emitter voltage. So what we have learned, here is the summary. We have discussed about different stability factors and expression for stability factor. So that's it from my side, and good luck and keep learning.